I would like to welcome from Germany, Joerg Sonnenberger. He will tell you about Fossil, which is a relatively young distributed version control system, and the sort of system that has become popular over the last about a decade.
It's a bit less actually.
Yeah, really.
So, I think something around 2005, the whole discussion of how is version control supposed to be in the future started. One of the late contenders is Fossil, and I'll go into it. Let's start with who am I? So I'm a software engineer from Rostock, Germany. Nice coast town. I'm a NetBSD developer, and that's part of the reasons I actually got involved with Fossil. More about that later. I've been a developer for Dragonfly BSD in the early age, and I've also been contributing to a lot of open source projects. Some of them like libarchive as one of the core developers. For others, for example, I have patches for GCC, LLVM, and lots and lots of other things. So let's start with an interesting question. What is Fossil? First of all, it's a distributed version control system. They are very hip nowadays. Everyone is complaining if a project is not using JIT for some reason. And Fossil tries to be an alternative to JIT. It's also a bug tracker. If you ever try to use GitHub for managing bugs, you will know that it's not fun. And providing a good bug tracker is something you need for any big open source project. And you also need it for work and many other things. Fossil provides a wiki engine. Again, this is something an open source project tends to need for documentation purposes, to help get the community involved. With the wiki engine is also a blog functionality provided. This, they kind of share a lot of background. I'll come to that back later. And most important, all this functionality is packed up. It's a nice small bundle. A normal build of Fossil is at the moment a bit larger than 1 megabyte. One binary, nothing more.
Sorry, may I interrupt? People who are here with their automobile and who need an uitrijkaart, I don't know the English word for it, they should get it before 5 o'clock, because then the secretary goes away. So if there are people with automobile, then be aware of the fact that after 5 you can get an uitrijkaart. I'm sorry to interrupt.
Is that important with bikes?
Sorry?
Is that important with bikes?
Is that not? No.
Okay, back to the presentation. If you compare this list, this is very similar to what GitHub offers, for example, as service online. So you want to get started to use Fossil. Well, first thing is you need to get this damn thing. You can get a pre-built binary, Windows, Mac OS X, Linux, and I think OpenBSD for Intel can be obtained from the website, or, well, you build it from scratch. The requirements for that are relatively small. You need a C compiler and you need ZLib. You might want to also use OpenSSL, but that's already optional. No other dependencies, which is quite nice for a software product. There's an option to use the system version of SQLite, otherwise the integrated version is used. And it's the same thing as for everything else. The build really only takes a few seconds, most of that for compiling SQLite, and after that you are set. So the most important thing you want to have first is look at the map. Those are basically all the normal commands Fossil offers. Important ones are things like add, checkout, commits. They basically behave a lot like the commands of the same name in Mercurial or in CDS. So there are no big surprises if you are familiar with either of those. And the most useful command for getting started is the second one. I'll show you what it does. It basically starts the integrated web server and tells your browser to go to it. This is actually the homepage of Fossil, which is just running completely inside Fossil itself. A few useful things every project has. The timeline is basically all the recent commits. Drawn nicely, the arrows are the relationship between individual commits. The light arrows are merges. What you're seeing here is are tickets. Those normal commits. A different color for commits on a specific branch. You have different filter options on the top, and well, you can browse the repository by files. There's a list of open branches. Fossil distinguishes between an open and a closed branch. Closed branch basically says, okay, I'm done with development here. I normally don't want to be bothered with it again, so you can filter those out. Yeah, tags. Tags are similar to branches, but they are not. They point to a specific commit, and branches are normally inherited by new commits. Yes?
Is CVS to Fossil your branch?
No.
I thought so, because it's a bit confusing, the CVS import.
Yes, I will talk about that later
Okay.
in the presentation. This is the old CVS to Fossil tool.
I thought so.
Which is, I think, written in Tickle. I'm not actually sure it still works at the moment. The problem was Fossil switched to the BSD license a while ago, and there was some code where the original developer couldn't be reached to agree to the switch. So some functionality was actually removed from Fossil at the time. And I think one of the features removed was required by CVS2 Fossil.
It doesn't look like it works.
I did some hacking on it to get it back to the state of working, but it didn't really work well for the use cases I had, so I started working on something better, but again, I'll talk about that later.
Okay.
You can get different reports for tickets. So basically, these are all the open feature requests. It's a long list, yes. Some of them are actually addressed, some not.
It was cleaned up last week.
Yeah. Yes.
Is there a future request for a tortoise port for Fossil?
I'm not sure. And, well, the bigger question is who's going to work on it?
Me and Red.
Okay.
So, yes, actually it would be quite useful for Windows users to have tortoise integration. Not yet. The most important wiki page ever, describing the actual wiki markup. And of course, the administration you won't see on a remote site if you aren't logged in with proper privileges. So let's go back to the actual presentation. You can play with Fossil yourself easily. Just do a clone of a repository and play with it. So what does it like? What does it look like on the big picture? In Fossil, everything is stored in a SQLite database. The repository is one database file. In a working copy, there's one special file which describes current checkout, which version, are there changes that can be undone, and so on. And this is essentially an implementation detail, but using SQLite has lots of important ramifications. Most of the content in the database is stored compressed using zlib's algorithm. The raw content of the file revisions is stored using a data compression algorithm. In the database there are so-called artifacts, which are blobs either for the content of a specific file in a specific revision, or there could be special metadata objects. That's like, for example, commits, tickets, wiki changes, all those special objects inside the database. And of course, Fossil is using SQL internally quite extensive, and it helps avoiding re-implementing sorting algorithms all the time, re-implementing filter algorithms all the time. So SQL is actually used as a high level in the implementation. When we are talking about commits in Fossil, we talk about manifests as objects in the database. They store things like the parent commit, and if it was a merge, also the name of the merged commits. It contains the author of the change. Contrary to Git, this is just a local username. It's not an email address. There's no separate submitter field. I don't know how many projects actually care about the additional fields in Git. I don't find them very useful. There's a commit message, of course. It should be Unicode, but this is not enforced. And when dealing with older repositories, it's quite useful that it's not enforced because you have all kinds of different character sets in it. We've been doing some work in NetBSD to cut this down. We not only had Latin 1 input, we also had some Japanese inside commit messages and so on. It's hard work to figure out what it actually was. The time of commit stored as UTC, of course. There was a feature request recently to also remember the original time zone. It was a person who's traveling a lot, and supposedly he couldn't figure out from the time where he was when he did the commit, but interesting. The manifest contains a list of path names, and for each path the associated checksum of the file. And it may contain changes to the tagging. If you want to create a new branch, you basically have a commit that says, okay, this tag starts here and extends to all later commits. If you want to stop a branch, you basically say, okay, this tag no longer applies after this point. And this is very useful because you can modify an existing commit and add a tag. So basically, you're moving. You can move a broken commit from the main line onto a special branch for broken or untested changes. The first thing you're normally doing when working with an existing project is you clone the source. So what is happening then? Fossil sends a request for cloning to the removed site, and it may get a request for authorization back if cloning is not allowed for an unprivileged user. It may, if this was successful, receive a bunch of artifacts as blob and a sequence marker to continue. And it will also request the configuration data next. And this ping pong goes on and on until everything is received. After that, Fossil is rebuilding its internal metadata. The important point is most of the additional data is not actually sent back and forth. This is all stored inside the manifests, which are compressed down. And the useful information it needs for operating efficiently is extracted from this database set and written down in a decomposed form. And that's basically the difference in architecture in the database scheme. On the one hand, we have persistent database tables. These are tables that are not dropped when you ask Fossil to rebuild a repository file. So they are two tables used to store the raw content, which is blob. Well, the name should be easy to understand, and there's a delta table which basically just links different entries in the blob table together. There are two tables for special artifacts. Private is basically just saying, okay, the following artifacts should not be pushed to another site when synchronizing with it. So if you want to do local changes or have some private sensitive data, you would mark it as such, and it wouldn't be transferred automatically. The second table is for so-called shunt artifacts. Sometimes you make a mistake. For example, you commit an extremely large file unintentionally to your repository and you want to get rid of it. Or someone wanted to be nasty, sued you for copyright violation, and you actually have to remove part of your project in a way that's disruptive to history. That happened, for example, for the BSD projects when they've been sued by AT&T in 1993. There's a table for the repository configuration. Part of the repository configurations are things like header and footer on the web page, or things like the logo, but there are also changes for optional behavior. For example, for small-scale repositories, Fossil can keep a special hash over the whole content of a commit. That's nice for small projects, but if you have, for example, something like the NetBSD source tree, computing this hash on commit time literally takes ages. So this can be disabled. There's an option to record logging attempts, especially if they failed. When a specific artifact is from, whenever a pull adds a new artifact to the database, the origin server is recorded. If you have a ticket, you sometimes have informations you don't want to push around. You don't want to push the email of the submitter around because, well, that's a source of spam. And this data is put into a separate table and basically indexed by hash again. And of course, there's a last table just for the reports in the ticket system. From these tables, there's another set we built, the artificial tables. For the sync protocol, we have the orphans, phantom, unclustered, and unsent. Unsent is basically an optimization which says, okay, these artifacts have been added locally, so we have to push them, and we don't have to ask the other side if it has those already. Phantoms are things we know about but haven't received yet. Orphans are delta blobs where we haven't received the other side for. And unclustered are part of the optimization for the sync protocol. I'll come back to that later. For manifests, we have the events table, the file name table, leaf, mlink, and so on. Basically, this is the manifest completely broken down into individual components. For For example, if you look at the timeline, it just queries the event table to get all the changes inside a specific time frame. The mlink table, for example, is used on update operations. It just contains which file was changed in which commit, and so on. For tickets, attachments, just as the name says, if you attach a file to a ticket, this is recorded here. The backlink table is special if you include a hash inside brackets in a commit message. It will automatically create a hyperlink to the other commit. Same in the wiki and in the ticket system. And to keep track of all those hyperlinks, the backlink table exists. And for the wiki, there's also a special cache of the last known revision of that file to be able to address it more efficiently. So we've already seen one part of the communication protocol, which is cloning. The synchronization protocol is protocol used when trying to update a local copy or a removed copy. It's stateless, so it requires independent reply-response rounds. This makes it possible to implement a server, for example, as CGI, because CGI doesn't really have a natural mechanism for keeping data around. There are two basic modes. It's either pushing data or pulling data, but they can be combined to run at the same time. So there's a special feature called the autosync, which is enabled by default, and all operations that normally modify the working copy or the repository, like for example the update command, is first asking the primary repository, do you have anything new? Oh yes, you have, give me that first. And after a commit, it will automatically try to push changes back upstream. This is very, very handy by allowing well, almost a centralized development style, and it avoids unnecessary branching. And I mean, if you look at the history of a big open source project using decentralized version control, it looks like the traffic map of any bigger city. It's not a nice history. So the first kind of request made during synchronization is the gimme request, which just asks the other side, I suppose you have this artifact. If you do, please send it back. Of course, it's useful to say, yes, I have this. So this is used to inform the other side what is currently available. There's a way to exchange configuration data. For example, the list of shunned artifacts. And the most important aspect of the synchronization protocol is finding out what is missing locally or on the other side. To mix it efficiently, there's a way to cluster the artifact list. Basically, they are a special form of artifact which just says, okay, I have the following 100, 200 hashes, and it means the request list can list only this cluster artifact once instead of all the 100, 200 entries inside of it. And going back to the earlier slide, the unclustered table are basically all the artifacts not already on a cluster list. At the moment, Fossil is normally restricting the unclustered table to about 800 entries. So for each push or pull operation, at most has to list 800 entries and one cluster. Handling bugs. Fossil allows the attribute lists of bug to be configured. It's using a typical dialect for that, and depending on the context, also SQL commands to extract and modify the behavior. Default classifications are the status of a bug. Well, is it still open? Has it been fixed? The type of the bug, is it a feature request, is it a defect, the severity, how important is it, the priority, should I fix it now or can it wait, and of course how it has been resolved. There's support for attaching files. This is one of the biggest limitations of GitHub, for example. It doesn't do that, and it's very annoying. For example, if you have a compiler project and you can't attach a test case, I don't know how you can actually use that thing. As I said, most of the behavior can be customized using SQL. For example, the reports are generated using a SQL command. And the output can be specified using the Tickle dialect and HTML. So, just as an example, this is a database command used to create the ticket table, and this is the embedded table used for specifying the HTML page used to add new tickets. Yeah.
We have about 10 minutes left.
Okay. Yeah, the blog and wiki, there's a typical small markup language for simple formatting rules. You can also use sanitized HTML. This can be all disabled if you want to use plain HTML without filtering all the time. It supports the usual page history, and you can mark things as event. Events appear in the timeline, normal wiki pages not. So, if you are not just a small individual programmer but have to interact with a larger community, it's sometimes useful to offer the option of using a different version control system. Fossil can import Git's fast import format, can also create this, and there are some tools to import from CBS as mentioned. The reason I started with Fossil was actually NetBSD is looking for replacement for CBS. And both Git and Mercurial has been investigated. They all have different issues in various ways, and I wanted to see how does Fossil behave for repositories the size of NetBSD. So I actually wrote a conversion tool. The goal was to be to behave as much like CVS as possible. Contrary, for example, to CVS to SVN or from CVS, creating bit precise output just like CVS would. There's one exception in an edge case, but even that is behavior CVS would give under some side constraints. And the conversion is now run automatically in a loop. For the NetBSD source repository, it needs around 2 hours. For the package source tree, which is a bit smaller, it's like 40 minutes. Yes?
The official way, as it looks on the Fossil website now, would be to import CVS to Git and then Git to Fossil. So I suppose your tool improves on that?
Yes.
Is it more accurate?
Yes. I'm directly creating a Fossil repository, and at the end of the import, you basically just have to rebuild the repository, and that's it. I have to update the Fossil homepage for that at some point.
Yeah, it's a bit confusing.
Yes, I agree. So what we have is a repository with around 250,000 commits, 350 branches, a working copy of the current state is around 2 gigabytes in size. The blob table alone is 1.3 gigabytes, including metadata. It's a 2 gigabyte SQLite database. I think it's the largest repository used with Fossil in any way at the moment. And the 350 branches, for example, are a problem for other tools as well. Mercurial had a problem with tagging. Basically, tagging in Mercurial is done by using a special file in the root directory, and it wanted to pass a file for every branch that was looking for tags. So something simple as showing the log of recent changes took literally minutes just to start. GitHub also has a problem with this many branches, so that's interesting.
One question?
Yes?
How did you test if everything went okay?
But basically I'm doing checkouts of the tip of every branch, doing the same checkout with CVS and compare the results. And they are supposed to be identical or, well, almost identical. There's one set of changes with keyword expansion, but that's acceptable. I've been benchmarking Fossil against Git by doing an export Git and using the same history structure. For most operations, Fossil is actually quite near the performance of Git. There's one big exception at the moment, and that's initial cloning. The problem here is that Fossil is using a very synchronous transfer protocol. And that doesn't work too well if you have such a large tree. And there's also the problem that the rebuild step with many large manifests takes a lot of time, because the total raw size of the manifests is in the area, I think, of 10 to 15 gigabytes, and it has to pass all of them. So I'm still looking at how to fix that. As I said, we now have automatically converted repositories with a latency between 2 and 3 hours for source, both with Fossil and Git. And as I said, it showed some interesting issues on GitHub too, so it was useful to point out bugs in other tools as well. Why should I want to use Fossil for a tool? Why should you? Well, first of all, because it's everything bundled up nicely, and it's relatively easy to set up Fossil either using CGI or using reverse proxy and running it as standalone HTTP server, and have most of the project infrastructure you would need for an open source project done, especially with relatively few maintenance issues. It's good enough in most areas compared to more specialized tools. I mean, if you have a really good setup for Jira or Bugzilla, it will be better, right? But it's good enough to be usable, and if you run into issues, it might be easier to just fix them in Fossil than to switch to something else. Using a database makes a lot of reporting issues very easy to do. So if you want to look for a specific commit, for example, it's easy to enable the full text indexing in the SQLite database and just do a query directly. What's also interesting for me is Fossil codebase is relatively same in the choice of algorithms and data structures, and that makes it possible to actually try out different algorithms to see if a specific hotspot can be fixed by just caching some more data and do that. Of course, there are also some issues. When is Fossil maybe not the right approach for you? Of course, Fossil currently uses hashes as identifiers both for tickets and for commits, and that can be a big problem from a usability perspective. If you want to have nice sequential bug numbers, for example, you might be more happy with Bugzilla. If you have already a setup like this, good, continue using it. You might be more happy that way. You might not like software that's not under GPL. I don't know. If you have a repository that is large enough to hit the issues I mentioned earlier, Fossil at the moment might not be the best tool for you. And one of the biggest missing features at the moment is there's no infrastructure for post-commit or post-pull hooks. It's been discussed. I think there actually is a branch for it, but it's not on the main line at the moment. That's it. Questions? Yes?
If you have a lot of attachments to tickets, then you have an option to not clone all those attachments. Because if you have, for example, a multimedia project like FFmpeg, we have like 600 gigabytes of files that show certain issues.
Right. At the moment, no. the question is most likely, do you want, if you don't include them in the clones, it partly defeats the point of a distributed bug tracker as well. I know the issue. I don't have a good idea of how to really address that. You could flag them as private data. It might be possible, but it hasn't been done.
Perhaps you can omit those related to tickets that are already resolved or something like that.
Right. Well, what you can do is you could shun all old huge attachments you no longer need, and those wouldn't be cloned or pushed around anymore. So it might be good enough to address it. It really depends on the specific use case.
Yeah. There's a project that's using the the Git file format for doing backup. It's called Bob, and they have enhanced it to be able to efficiently handle very large binary files. Basically, they have a rolling window checksum, so that they break up the binary in nice blobs. And I think also for projects like this, where you have large files, it would be very nice to have this. Also because you could start using this as, for example, a replacement for things like Dropbox or CMSs.
Right. The question is, what do you want to use it for? I mean, a version control system for binary files is always a bit problematic, because basically you often can't use efficient delta algorithms, because binary, for example, multimedia files tend to change a lot just with minor changes to the file. For example, they tend to be already compressed, and it's difficult to deal with them efficiently. Cutting them in smaller blocks would be a possible way to address it. I'm not sure. It wasn't really an issue so far because no one used it for that. So maybe in the future. Other questions?
No more? Okay.
Okay, thank you for your attention.
Very good.